All right, here we go. Guys, we have one more topic left, and that's really about it. And that's how to graph. All right, all these different figures. So it's gonna today and Friday is it. All right, today and Friday is it. Really, after today, you probably could do Friday anyway. So now you guys know how to graph points. Now let's put all these points together and start graphing some figures. All right, I'm gonna start with the very basic, very basic figures first, and then we'll increase in difficulty here today. All right. First, look at my first one I'm going to graph with you. It just says R equals 5. That's it. And if you remember, when I showed you how to graph a point, all the points came in. R was your first coordinate, and then the angle was the second one, right? That's how all these points come in the polar form. Well, here's what R equals 5 means. I don't care what angle you go to, the R value is 5. So if you go to 0, R value is 5, which means for us, 5 units or 5 circles away from the pole to the center. So you go 1, 2. I'm going to count that. I'm going to count this one as a circle, by the way. All right. So go 5, 1, 2, 3, 4, 5. Again, R equals 5. That's all it means. Hey, there's no theta, so any angle I go to will be 5 away. So as you guys start plotting a couple more now, you'll start seeing our first figure here today. Again, no matter what angle you go to, it's going to be 5 away. Darn right. What we know is a circle. Will it change if I make the R value negative? No, right? All right, say you go to 0. Well, instead of going to 0, you're going to go in the opposite direction because it's negative. And now you're going to go 3 away in the opposite direction. 1, 2, 3. Even if you go in the opposite direction, you're still graphing 3 around, right? 3 away from the pole. So R equals a number will just be a graph of a circle. Before we move on, look, unlike the matrices unit, I'm not going to hide how your calculator can help you now. All right, I expect you to check to make sure these graphs look like what they should. So go to your calculator. I got to show you how to graph in polar on the calculator. So I'll do the first one, R equals 5. So go ahead, grapher. Everyone go into the grapher. Clear out whatever's there. I don't know if anything's in there, but get it out of there. All right, well, first step is I got to put R equals in there, right? I got to put R equals. There's 2 ways you can do this. 2 ways. You could have the R key, which is number 4. So you can go shift 4, or you can just hit enter, and up will pop a bunch of templates if you just hit enter. Unfortunately, if you want to use this, R template's all the way down at the bottom. Everyone see that? R equals at the bottom, and it says polar equation. So you can either literally type shift 4 or hit enter and look for the R equals template. All right, get that out of there. All right, so let's clear that out of there because we just want R equals 5. So is everyone all right getting the R there? 2 different ways. All right, hit enter. And now we want this thing plotted and graphed. And you guys will see, hopefully, yep, there we go. We got a circle now. There we got a circle. Anybody's off because maybe you're on a different set of axes? Just go up to auto and hit auto. Make sure you hit enter on auto. Yep. All right, I know it's basic, but once we get into the more hardcore graphs, this will be useful to know if you're doing it right or not. All right, we ready to move on? So R equals a number, just a circle. All right, let me start throwing some cosine, sine at you now. Okay, let's start throwing some cosine and sine. What effect does it have on it now? Because it's just not R equals 4, it's 4 cosine. So from here, since it's not just going to be a plain old basic circle, I'm going to have you fill out a table and graph those points. All right, so that's the process now. Fill in the table, find your points, and then we're going to graph them. We're ready. All right. Well, no, you're not ready. Here's why. Anybody see all our angles are in what? So you better be ready to tell your calculator you're going to be putting in radians. Better be in radian mode. Okay, so make sure you're in radian. And look, you're going to have to do this every day because I'm reviewing for the geometry regions with my other classes, and they're always in degree mode. All right, so be prepared coming in every day now. Make sure you put your calculator in radian mode for me. So I'm giving you the angle measure. You're going to find the R value by typing it in your calculator. So what's at theta equals 0? So 0 degrees, what's my R value? All you guys are doing is substituting in 0 for theta. Now go to your calculator. 4 cosine, go to your calculation screen now. 4 cosine 0. There's your R value. 4. Put the two together. Oh, easy, easy. I know it's a little backwards on your table, but the R value always comes first. So 4, 0. Now, can we just make a quick decision? Do we want to just fill in the table and then graph, or graph as we fill in? Fill in the table and then we'll graph? Okay.
Oh, wait, no. No, fill in the table.
Fill in the table first.
It doesn't matter to me. I guess we'll fill in the table and then we'll graph. Okay, so now you're plugging in pi over 6. So 4 cosine pi divided by 6. Make sure you're in radian mode again. All right, we could just round to the nearest tenth here. All right, about 3.5, that's fine. So 3.5 comma pi over 6.
I don't know, but he's not in graph.
No, I'm not graphing this. I mean, this is all calculations. Yeah, this is all calculations. I got to fill it. I'm on the calculation screen now. Grapher I'm only using after I'm totally done to check.
Oh, so
That's all I'm using Grapher for.
So these are all the YLs.
Correct. Yes. I will always provide those for you.
So just round it?
Yep, just round it for me. So I don't think you need to round the next one though. Should be 2 here. Pi over 2. Guys, keep grinding away here. Oh, everyone see 2 pi over 3? Mm-hmm. What'd you get there?
Negative.
Yeah, ooh, -2. We better watch it, huh? When we graph that one. This is why I spent 2 days graphing points with you guys. Want to make sure we're all on the same page before we graph it together. Make sure our points match. And yes, I will always provide the table for you. Okay, so you just fill in. Ready to graph? Okay, here we go. 4, 0. So I'm at 0. I go 4 away from the pole. 1, 2, 3, 4. 3.5 pi over 6. And look, everything's conveniently labeled for you guys. You're welcome.
Is it always gonna be like
Yep. Now, the only thing I'm going to warn you about, keep track of what you're plotting because you have to connect them in that order when we're done here. Okay, just not connect the dots where you go anywhere you want. All right, we got to connect them in the same order we plot them here. So 2 pi over 3. And I am the worst at this because I cannot see where the lines are at all. So you're just going to have to bear with me. Hey, real quickly, 0 pi over 2,
Just put it down the middle.
the pole. Thank you. Give it some respect.
so you just do it like this.
Yep, so when your R value is 0, it's going to be right at the pole. Ooh, negative now. What happens here? 2 pi over 3? Hey, 2 pi over 3, I shouldn't see a point right here, right? We should see it on the 180 degrees opposite if it's negative R value. Keep that in mind. Oh boy, so 2 pi over 3, where's that going to be 180 degree? 5 pi over 3? Is that where it lands? Right here? Negative 3.5, 5 pi over 6. Just be aware of the negatives. That's all I ask there, kids. Be aware of the negatives. Oh, then what starts happening here?
Repeats.
We start plotting the same points again,
Yes.
right? You're going to start once I get to negative 4 comma pi, I'm going to start plotting the same points again. What? No, it's not a pentagon. No, sorry.
It's not pentagon?
No, not even close.
I swear that's a pentagon.
Hexagon.
No,
That's
not
it.
even close.
8 is octagons. Oh.
It's not hexagon. Hexagon's 6.
Then is it, I don't know, is it just
I
a
thought a
circle?
pentagon was anything less than that. I thought like an octagon and a hexagon were pentagons.
No, but. Is pentagon not 5?
Yeah.
Then how the hell is an octagon and a hexagon both? What?
Five is a pentagon, but a pentagon's not only 5. Maybe. Ask him.
What are you
He's a
talking about?
geometry.
What are we asking?
Oh, shit,
What
right?
shape was that?
What was a hexagon? Was it just a
It's
circle?
not an octagon.
Yeah, it was a hexagon.
Isn't-
He said
When
it's
When you check, that's why I'm showing you how to check. Notice you guys have a theta, right? You can just type in X when you check because watch what happens when you do that. It'll automatically, oh, never mind. I thought it automatically turns it into a, yeah, there it is.
Oh my
Yeah,
God.
automatically turns it into a theta for you. I knew that was going to happen. Yeah. So what is it? What is it? It's a circle.
What?
Come on.
It's a circle.
What
So
is it not?
you end up with a circle.
They're edges.
And remember, hey, we're not graphing every single point here. We're only graphing certain points. You know, if we graphed a couple points in between here, we never graphed at pi over 4. We never graphed halfway in between here at 7 pi. It would be a circle.
If you connected it with straight lines,
Yeah, what would it be?
shape would that be?
It would be a circle.
No.
What is circles
Like,
don't have straight lines?
if you connected each
So you're
dot
just
with
saying
a
It has
circle-
corners and
hypothetically.
edges. A circle doesn't have corners or edges.
If it looked like that, it would be a hexagon.
No.
Right? No.
You watched it.
But then also pentagons are just 5 sides.
5 side is a pentagon.
Yeah.
So
Octagon
it
is
is
8.
hexagon or
6 is
octagon.
hexagon.
I said pentagon.
Wait, I was right this whole time.
No, I said pentagon.
But it
5
doesn't
is a
have
pentagon.
five
I'm not arguing what it's a circle though. That's what it ends up being. You guys just have to realize as you're arguing with me that we only graphed a certain amount of. We didn't graph every single point around. Okay, if we did, you definitely tell it was a circle.
Oh, I got it. It is 6. It's a hexagon.
Okay, hey, I want to move on here because we still got 3 more graphs to go. Any questions here? So, hey, a number with cosine multiplied by cosine is a circle. Not only that, hey, I want you guys to see a little bit of this so you know how to check real quick. Notice the number out in front was a 4. How far does this go out? To 4. Okay, so that's how large you can tell your circle is going to be. So I go to this next one. Now I'm replacing it with a sine instead of cosine. So how is that going to differ? Well, let's graph it. I can guarantee you're still get a circle because any number times sine or any number times cosine is going to result in a circle. But watch how this circle is different. All right, go ahead. Now you're doing 6 sine of these angles.
Did cosine start at max?
Everyone getting 0, 0? So we're going to start this at the pole. Pole. Round to the nearest tenth.
And she took forever. Why are we
You could ask for
5 and then what? 2?
Ready? Okay, let's graph it. We know it's going to be a circle. Let's take a look what it looks like. So it starts at the pole. 3 pi over 6. (5.2) pi over 3. Again, be in the ballpark of 5.2. And remember, we're not graphing every point. If we graphed every point, it would start more looking like a circle. But I'm already hearing whining about graphing these many points, so God forbid I ask for more.
Where did you say?
Do you notice that it goes out to 6, though?
Yeah, that's
Which is the number out in front.
Just a circle. Just a circle. It was all in motion.
And then once you start hitting pi again, we start repeating. Well, not repeating, but graphing the same point.
Yep, this math is when people say kids. You know what also pisses me off when people say Nevada.
I think I could see it being 1, 2, 3, 4.
Wait, what do I even say? Where the fuck?
Which one do you ask?
My brother says Nevada.
Maybe it's yeah.
So it's not X.
How's our circle looking here?
Very circle.
All right, real quick before I move on, because the next one's a totally different beast. No more circles after this one. The difference between this one and the last one was cosine, this one was sine. Anybody notice anything different about the graphs? Other than obviously one was bigger. Where was the cosine one located? What do we call this right here? If I drew in both here, my old school, that's the what? X-axis, right? So the cosine one landed on the X, and where'd the sine one land? And I know I'm really just
Do we need to know
grasping for straws here, but maybe. Anybody remember pre-Regents days? Cosine was always associated with
X.
the X coordinate, and sine was always
Why?
associated with the Y, so that's why. Hey, real quick, hey! Let me say I put a -6 sign. You know where it's going to land? On the negative side. Okay, so at least you can predict. I know you can check it on your calculator, but at least you can predict where the circle's going to be. All right, we ready for this next one? No joke here, no more circles, because look at the equation. Now I'm adding and subtracting a number to it. So this is not going to be a circle anymore. Ooh, ready for this one. All right, let's do it. Fill in the table for me. Should be doing 5 minus 5 sine 0, 5 minus 5 sine pi over 6.
Oh, that's an interesting fraction.
Yeah, I just gave you freaking 25. Yeah, so you must bottom of the pack.
Are we singing? What? I can't even hear what she's saying.
No, she's.
I have no idea what you just said. What did you just say?
She was doing that song. She was French.
It
No, it's
sounded like
And I hope you can find these points tomorrow on your own instead of just copying what I have up here. First thing you notice right away, R value, none are negative. So I hate to break it to you, you're graphing all different points now. All right, none of these are negative, so don't be prepared to graph the same point again. So we're gonna have to make sure, again, we keep track of what order we're graphing them, because that's how we connect them. Ready to roll? Again, take your time here, because you're gonna have to graph a lot of points. They're not gonna start repeating again.
Just forget it. Just forget it.
Be careful with that 0.7, 0.67. That's going to be a tight one there to the pole. And then we come back to the middle.
How do you graph beta 6?
Like a, what are you doing?
How does this even? Wait,
2.5.
it looks like a wait.
Oh, it might be.
It's really good.
Oh, I kind of did.
I just put all of them in my calculator and now I'm typing them down. But I got 2.6 instead of 2.5 for pi over 6.
Okay.
Bad.
Okay.
Well, I didn't know.
It's really ugly. It's not how it's supposed to be.
Okay, here we go now. Again, I can't stress this enough. We are not graphing every single point on the polar grid. All right, so you want to know what this looks like before you actually put pen to paper, graph it. So it actually looks like what it should be looking like instead of you guys just trying to draw whatever you think it is by connecting the dots. So go ahead, go to Grapher and type this in so we can see what this actually should be. Because I don't want you guys just doing some straight lines, connecting whatever points you think are right. So what is this? R equals. And that's what you just graphed there.
Oh, yeah. So it's just a really ugly. It's round like. Oh, it's what? Well, it's round. Okay.
And yeah, so it's killing me to have that up on the board. To something I don't have.
Nice try.
This will only work. Heads up. This will only work. Whoa, before we go to the last one. You're only going to get, by the way, let's go official here instead of going heart. Cardioid graph.
It's like cardiovascular.
Oh, great job. There you go, Richie. There you go. Good work. There you go. Connecting the dots there, literally. Yep. Cardioid, cardiovascular. Yep.
Wait, why is that?
Last thing before I get to the last one. That only works if these numbers are the same. Okay? Take a look at the next one you're about to do. Are the numbers the same?
No.
So it's not going to be a cardioid. Don't expect a heart. You're going to expect our final type of graph here. We had circle. We had cardioid. Now the numbers are not the same. Okay, numbers are not. But predict here. What axis probably is this going to be on? Probably the X because it's a cosine. Good. All right, but the numbers are not the same, so don't expect a cardioid. Wait till you get to the name of this one. And remember, we got to connect them in order. That's going to be clutch on this one.
Be honest.
harmonic algebra. If the shoe fits.
Actually, what is that?
They are. It's okay. I
Big-ish.
Oh.
Shit.
Okay, I'll round down to an 8. Okay, then I'll round down to 7.5. Actually, I am a 7. Same. Okay, I'm like
It's weird.
8.5.
But then
Okay,
some
I'm
shoes I'm
literally
literally a 7.
I don't.
I can speak.
Watch when you approach the negatives.
Oh, I can. Some search.
It's like throwing water on the ledge.
I can squeeze into like my Air Forces that are 7s and stuff when I'm out. So they're probably like years, but like not the tiniest bit.
The kids.
Someone else has.
Stop.
It's a little too far. Not far enough for you.
Did we keep track of the order we graphed these, huh?
Oh, yeah, mine looks like that.
Because I got a lot of dots there, but I can only connect them the order I graphed them.
It's a little bit.
I think it's,
Yeah, that's what mine was supposed to be. That's what mine was supposed to be. It's technically a circle.
Okay.
Thank you, James.
Oh. Whoa, what?
what's that shape called?
Oh, I'll tell you in a second there, boss. This is how I'm ending the show today.
3D circle.
How do I go about drawing this?
Follow the dots. We started here.
I did that wrong.
Oh, I see.
No, stop it. I don't know what. No, I'm just confused.
Boom.
I should have stuck to this. Just a earthy shape.
Okay, I got it.
Wait, I don't.
I got it. I love it.
Bro,
I got this. Mine look.
I have all the extra stuff.
Mine look like that.
no, this is before. Can I get your go?
I thought you didn't like my drawing.
I will.
Oh, it's good.
Everyone's got it looking like this?
Yeah.
Yes.
Again, here's how I'm going to wrap it up. Those numbers are the same. It's a heart, cardioid. When they're different, this is what's called a, if you want to try to pronounce it,
Yeah.
Limason. Limason. This is called a Limason. Lemiscon. A Limason. So you'll practice graphing all those tomorrow
Wait, what?
on your own.